rotations are a type of transformation in which the geometric fixture is turned about a point that is fixed. And that point is called point of rotation. Okay, the number of degrees the figure turns is the degree of rotation. And you can rotate either clockwise or you can rotate counterclockwise. Okay, and a rotation is a rigid motion. Okay, because it's not changing shape or size. All right, so the notation for the rotation when you're writing your rules is it uses a lowercase r. Remember, we had an uppercase r. That was for reflection. So to tell the difference between a reflection and the rotation, we use a lowercase r for the rotation. Okay, then in our parentheses we have the angle of rotation, so in this one it's 90, and then the center of rotation. If it has O, that means it's about the origin. And then you put your triangle or your quadrilateral or whatever you're actually rotating. Okay? All right. If we're doing, and if it's, there's nothing that says any, whether it's counterclockwise or clockwise, you always assume counterclockwise. Okay? All right, so the algebraic rules, when you're going to go from a 90 degree, if you think about it, if I'm going from this point right here counterclockwise to make a 90 degree, my point's actually going to kind of move, and it becomes over here. And the rule for a 90 degree is that my xy becomes a negative yx. Okay, so let's go ahead and graph one. We have a vertice at -5 and 5. We have one at -1 and 1, and -2, 2. Okay, I'm going to rotate the origin counterclockwise 90 degrees about the origin. Okay, so if I want to write that rule in notation, I'm going to have rotate 90 degrees about the origin, and I'm going to name this ABC. Okay, so ABC. All right, now one of the key things is that from the origin, that points, each of the points has to say the same distance. Okay, and so what we can do is we've got a distance of 2 diagonals, so 1, 2, and if I make it into that 90 degree, oh, wait a minute, I just went, sorry. That's clockwise. I went the wrong way. So 1, 2, that's going to be 90 degrees. That's going to give me my C prime. Okay? And then if we think about it, you can continue in rotating everything around, but once you get that first point, the other thing is that the rule is that negative yx makes it much easier. So if I had negative 9, 1, that was my A point. That means my A prime point's going to be, because this was xy, is going to be negative yx. So that means I'm going to have a negative 1 and a negative 9, because I changed the sign of the y, and then I changed this, and then I put the x there. So I'm going to go over 1 and down to negative 9, and that becomes my A prime. Then I need to do the same thing for B, because if you take this shape and you're rotating it about the 90 degrees, okay, all the way down, but it really, honestly, I think it's easier to do it with the algebra. So B was y was 5, so now I'm negative 5. X was negative 5, and so I go over, go over negative 5 and down negative 5, and that's going to give me my rotation, which looks right when you kind of just go down. All right? Okay, let's do another one. This time we're going to rotate it clockwise 90 degrees about the origin. So if I go ahead and plot my original points, so negative 5, 1, 2, 3, 4, 5, and C is negative 2, 2. Okay, there's my original. Okay, this time we're going to go clockwise like I tried to do last time, so that means my C is going to go here. I'm going to go 90 degrees. Well, 90 degrees clockwise is the same as going 270 counterclockwise, because if I went from this point 90 degrees clockwise, that's 90 clockwise. But if I went counterclockwise, I'm 90, 180, 270 counter. So I'm going to use this formula here, which tells me if I change my y, or change everything to a y negative x, I'm going to have rotated it. So that means my A prime is going to become y is 1, negative x, so a negative 9 is going to give me a positive. My B prime, my y goes first, negative gives me a positive, and then C prime, y goes first, negative gives me a positive. And now I can plot, so I'm going to go up 1 and over 9, and that's an A prime, and I'm going to go over 5 and up 5, that's my B prime, and then my C prime, and that's exactly, you can tell that it actually moved. Alright? Okay. Now, if we want to do one that is about the point, and we're not just doing at the origin, okay, what we have to do is we need to subtract the point, the rotation off the vertex that we had, then do the rule for the origin, then put the point back in. Alright, so here we go. We're going to go counterclockwise, and so we're going 90 degrees. So counterclockwise, 90 degrees, my rule was xy is equal to negative yx. So xy becomes negative y and x. Okay. Now, my first point is negative 5, 5. and I want it about the point of 1, 2. So that means I'm going to have rotating, small r, 90 degrees, about the point 1, 2, and we'll make it ABC again. That's my rule. Okay, so first step is subtract the point from the vertex point. So I'm going to subtract 1 and subtract 2, and that's going to give me -6, 3. Okay, now rotate like you normally would. So I'm going to do -yx, so that would make it -3, -6, and then add the point of rotation back to it. So now I'm going to add 1 and add 2, and my final point is going to be -2, -4 for A prime. Alright, so here's my point of over 1 up 2. That's my point of rotation. My original point was -5 and 5. And my new point's going to be -2, -4. Okay, so I'm going 90 degrees about the counterclockwise, so that makes sense. It's going to go there. And if I had been in the origin, if you think about it, if I had been here, it's just going to be about a little here. So it's kind of like it shifted up a little bit. But then I just need to do that for each of the points. All right, so let's do B. I had -9, 1. I subtract off my point of origin. That gives me -10, -1. I apply my rule, so I'm -1 gives me a +1, and x is -10. And then I'm going to add my point back on, and I'm left with my new point of 2, -8 for B prime. So over 2 down -8, and that's the B prime. Alright, last one. Let's do point C, and I started at -2, 2. I subtract my point of rotation, and I get -3, 0. Apply my transformation, so that's going to make it 0, -3. Add my point back on, and I'm at 1, -1. So I'm going to go over 1 and down 1, and there's my C prime. Okay? All right. What I'd like you to do now is try and do this one by yourself, and then come see me and we'll work through it, check it together to make sure, and then we'll go through writing the rules for the rotation together as well.